Physicists found the equation for a shortcut through space. Then they found the one thing standing in the way matter that, according to everything we know, shouldn't exist. Here's the setup. In 1935, Einstein and Nathan Rosen were studying the math of general relativity when they noticed something strange hiding inside the equations. A bridge connecting two distant points in space-time, like a tunnel folded through the fabric of the universe itself. Decades later, physicists gave it a name, a wormhole. The math wasn't the problem. It never was. The problem was what it would take to keep one open long enough to matter. Picture a wormhole as a throat, a narrow passage stretched between 2 points in space. The moment it forms, gravity does what gravity always does. It collapses the throat, instantly, faster than light could ever cross it. So for a wormhole to actually work, for anything to pass through before it snaps shut, something has to fight back against that collapse. Something has to physically hold the walls apart. That something is exotic matter. Specifically, matter with negative energy density. Now here's why that single requirement breaks almost everything we understand about the universe. Every form of matter ever measured, every star, every planet, every atom in your body, carries positive energy density. And positive energy does one thing. It pulls space-time inward. It's the reason gravity exists at all. Negative energy density would do the opposite. It would push space-time outward, propping the throat, open the way a steel strut holds apart the walls of a collapsing mine shaft. This isn't a small technical detail you can wave away. General relativity has something called the null energy condition, a rule so fundamental that almost every known form of matter obeys it without exception. It says, in essence, energy density measured along the path of light should never go negative. A stable, traversable wormhole needs to violate that condition, not bend it slightly, break it outright. So the real question becomes, is negative energy actually real? Or is it just a convenient plug physicists invented to make the equations behave? Here's the twist that keeps this from being pure science fiction. Negative energy density has been observed. It has a name, the Casimir effect. Take two uncharged metal plates, place them extremely close together in a vacuum, and something strange happens. The quantum vacuum between those plates behaves differently than the vacuum surrounding them. Fewer virtual particles can exist in that narrow gap than outside it. The result is a real, measurable region of negative energy density, confirmed in laboratory experiments, not just predicted on paper. So exotic matter isn't fantasy. It's sitting quietly in physics labs right now, in quantity small enough to measure but real enough to matter. And that's exactly where the dream collides with the wall. The negative energy produced by the Casimir effect is almost unimaginably tiny, a fraction so small it's almost embarrassing to place next to what a wormhole would actually require. Calculations suggest that holding open a throat, even a single meter wide, would demand negative energy densities on a scale that dwarfs the total mass energy of entire stars, somehow compressed into an impossibly thin, impossibly stable configuration and sustained indefinitely without collapsing. We're not talking about an engineering gap you close with better technology. We're talking about a gap so vast that some physicists question whether it can ever be closed at all. That hasn't stopped people from looking for a way around it. Some researchers point to quantum effects near black hole horizons, where extreme conditions might naturally generate concentrated negative energy. Others look towards string theory, where certain exotic field configurations could theoretically produce the densities required. Still, others argue that quantum mechanics contains loopholes we simply haven't found yet, ways to concentrate negative energy far beyond anything observed so far. None of these ideas are confirmed. Every one of them is active, contested, unresolved research debated in physics journals right now. And here's the part that should really sit with you. We are not blocked by imagination. We're not blocked by rockets, fuel, distance, or time. The equations describing a shortcut through the universe have existed for over a century. What's missing is a form of matter that may or may not be achievable at any usable scale, And right now, nobody actually knows which. That's the real story of wormholes. It was never a fantasy locked behind bad engineering. It's a genuine doorway, sitting fully formed inside the mathematics, held shut by a single unanswered question. Can negative energy density ever exist at the scale reality would demand? Until physics answers that question, every wormhole stays exactly where it's always been. One equation away, and one impossible ingredient short. So here's what's worth sitting with. If we ever solve the exotic matter problem, if that wall ever comes down, should we open that door? Tell me in the comments. Would you actually step through a wormhole if we built one?